Guys, welcome to today's lesson for Thursday the 4th of March, which is really around the binomial distribution and finding the expected value for a binomial distribution. So we're just going to look at the textbook. This is page 358, example 25, and the theory above it. Just trying out this video solution, seeing if it works. Let me know if it doesn't, or how I can prove it. So just you'll notice in this part in the formula here, it says if x is a binomial, so if the random variable x has a binomial distribution, then with the parameters n and p, then the expected value of x equals n times p. Okay, so we've learned how to do expected value before, and for the binomial distribution, the expected value is just n times p. And the variance of the binomial distribution is n times p times 1 minus p. Remember, variance is like a measure of spread. It's the average squared distance a value is from the mean. And just for now, know that it's a measure of spread. And in a minute, you're going to be comparing expected value and variances for two different distributions. So let's look at example 25. You might want to write that yellow bit in your notes. Example 25 says this: two machines and a light bulb factory are being inspected because quality control raised concerns. Managers have found that the probability that the first machine produces a defective light bulb is 0.3, and that the probability that the second machine produces a defective bulb is 0.2. So you've got two different distributions. Inspectors take a sample of 6 bulbs from the first machine and 5 from the second, and then they use the following parameters. How do we get these values? So B is x, the random variable x belongs to the binomial distribution. N is 6, or there is 6 trials, you could say. P is 0.3, that means the probability of being defective is 0.3. That's for the first machine. And for the second machine, we'll call that random variable y. It's a binomial distribution. How do you know? Because it's got a fixed number of trials, 5, and the probability of being defective is 0.2. So it's good to write out the parameters of each of those distributions. It says here, compare and contrast the central tendency and spread of these binomially distributed random variables. Compare and contrast means look for the similarities and then look for the differences. For the central tendency, that's like the mean or median, and the spread of these binomially distributed random variables. So first of all, we have to calculate the central tendency, which is the mean, and we just use that formula which we found up here, n times p. So for the random variable x, you just multiply them together. 6 times 0.3 is 1.8, and the expected value or mean for y is 3 times 0.2, which is 1. What does this mean? It means that on average, if I chose 6 bulbs from the first machine, I'd expect about 0.8 to be defective, and from the second machine, I'd expect about 1 to be defective. So how do we compare? We say the random variable x has a higher value, 1.8 is higher than 1 on average. Twice as many defective bulbs are predicted to appear in the sample of 6 than in the sample of 5. So that's how you might answer that question. Okay, so that's central tendency, and then spread, we use this formula here. The spread of x is n times p times 1 minus p, which in this case would be 5 times 0.2 times 0.8. I'll just show you that over here. Dun, dun, dun. Okay, 5 times 0.2 times 0.8, and the random variable x is n, let's do 6 times 0.3 times 1 minus 0.3, or 0.7, which is 1.26. So 1.26 has a variance of, that's the variance of x. 0.8 is the variance of y. How do you compare these and contrast them? Well, we say that there's more spread, it's a higher spread in x than the random variable y. What does that mean? It just means that we're going to get a wider range of results around the values of x, or the outcomes of x, than we are for the outcomes of y. Okay, and so that's all you really need to do for expected value. What I'm going to ask you to do is do exercise 7L. Now you might want to spend some time having a good go at 7K, because there was quite a bit of information yesterday that you had to get your head around, and I just want to acknowledge that. Some of you are probably going, oh, so much stuff. And there is, so just take your time, read through the textbook notes, get your head around it, but also have a go at 7L. Just do, say, questions 2 and 4, or 2, 3, and 5. Just have a mix of 2 or 3 questions. Actually, there's 8 questions, so try and do at least three different questions there. Let me know which ones you'd like to go over, and I can do video answers for some of these if you want. You'll notice that some of them actually are a repeat of yesterday's types of questions, but they will involve finding the expected value and the variance as well. Okay, hey, all the best for today. Let me know how I can help, and we'll see you for our next lesson on Friday.